Hi and welcome into another LEETCODE challenge. Today we are dealing with an easy one, symmetric tree. Given the root of a binary tree, check whether it is a mirror of itself, so symmetric around its centers. As we can see on example 1, we have a tree which starts with 1, then we have 2, 2, so those are symmetric, and here we have like a change, so 3, 3, and 4, 4, and that will make true, so it is a mirror. And then we have example second, like 1, so that's okay, 2 and 2, that's okay, but here we will have a false, because here the tree is on the right side, and here also on the right side, but it should be on the left side. So that looks it. Very brief descriptions, and let's get back to the console and see how it worked out. Alright, so we are back in the LeetCode console. I will be using JavaScript, but you can use many other languages as well. We had similar problem lately that we were checking if binary tree is exactly the same. Not the mirror, but exactly the same. If you didn't saw that problem, I will link it down below. But then, in that particular example, we used recursion to traverse the tree because we didn't know how deep it can go. We will use more or less the same mechanism here, so we will also utilize recursion, and we will create a special function for that. So as it needs to be a mirror, and this here is symmetric, so let's do a function called isMirror to be in the same convents, and let's do function, and it will accept two trees because we need to check if left side is equal to the right side, so actually we are dividing that and going one by one. So let's maybe do T1 and T2 to make it simple. And now what we would like to do, for sure we would like to create in recursion a base case way where there is nothing else to do. So in our particular example, it will be that both of the nodes are null, because if we approach this particular place that the nodes that we got, like T1 and T2, are both null, we firstly know that the tree on the left side and right side ended, and the second one that they are the same because the values are just null. The other issue would be that if one of them would be null and the second would contain some kind of a value, because then we would know that there is a mismatch. But this will be actually another conditional. So let's do the first one. If T1 equals null and T2 equals null, we will return true, and then the recursion, because we know that we ended this particular problem and it is a mirror. Now we will code the second thing that we discussed. So if T1 is equal to null or T2 is equal to null, then we will return false, because as I mentioned before, one of them is null, the second one isn't, so we know that there is a mismatch. And now we have our base case, so we have our recursion stuff. So what we would like to do, if it's not null and one of them is not null, we need to compare the values. So we will do T1, let me check, it should be at val, yeah, it's at val. So T1 at val needs to equal T2 at val. So we are comparing the values. And now the recursion case. So we have left side and the right side, and we need to check. So if we have two nodes on this level and two nodes on this level, we need to check T1 left to to 3 to right. So we will do such recursion is mirror, and we will pass t1 left and t2 right. And as we dealt with this and this, we also need to take care of this and this. So we will launch it one more time, but now we will pass t1 right to t2 left. So we will be, how it will work, we will firstly start here. Then, so we will firstly start here, so maybe let's launch this function. So let's do return here is mirror, and let's pass just 2 times the root. Let's see how it more or less should work. So maybe let's firstly run it, check if we did it okay. Yeah, both cases are accepted. And let's see how it would work in this particular example. So we will start here at root. Then the recursive function would run, and we would have this. So we would check if 2 is equal to 2. Firstly of all, we would check if they are not null. They are not null. Okay, one of them is also not null. So we skipped this, we ended here. So we firstly start to compare the values. 2 equals to 2. Okay, so we are launching the recursion. So we are taking t1 left and comparing it to t2 right, and we are launching t1 right and compare it in t2 left. And due to this recursive nature, if there would be another levels of this tree, it would go deeper, deeper, and deeper until it would run out of options, so t1 and t2 should be null. So that's basically idea about this solution, and let's click the full submit. And we are good. So that's all for today, and see you next time.